Hi, my name is Alan Kenyon, and I'm a project engineer for DST Controls. EandM has asked me to share a success story where we use the SICK inspectors on a project. So a little about us at DST Controls. We are a system integrator out of Benicia, California. We've been in business for over 30 years now. We service clients in the Bay Area, Northern California, and the Western United States. We do a number of different things here: control panel manufacturing and design, PLC and control system programming, and industrial data. DST Controls, I work in the industrial data group. We focused on bringing data from industrial processes to the people who need it most, such as site managers, maintenance people, when people need to order new materials, just understanding the data coming from these processes and storing it. So in my group, we do a lot of database installation and administration, custom software solutions, web applications, dashboards, and reporting. Okay, so the client I'll be talking about today is a high-quality chocolate manufacturer. The specific factory we worked at was in Northern California, and this factory produced chocolate chips and chocolate chunks on an industrial scale. Each day, the factory would produce about 4,000 boxes of chocolate or 100 super bags of chocolate. Each box would weigh between 25 and 50 pounds, where each super bag would weigh 2,500 pounds. So in any given day, the factory would output around 250,000 pounds of chocolate. So the issue that the client was running into was a packaging issue. So we'll start by walking through the packaging process. So the first stage in the process is assembling the flattened boxes and constructing them. So you can see here, this is one of the assemblers. They put in flattened cardboard boxes, and the machine assembles and tapes the bottom of it. You can see a box on the far right going through the wall into a packaging area. I've had to blot out all the logos on the boxes, so you'll notice a lot of black marks everywhere. Once through the wall and into the packaging area, the next machine inserts a big blue plastic liner into the box. This is to protect the chocolate and seal it from the cardboard. This machine here will fill the box full of chocolate. The molding lines for the chocolate are way overhead, about 60 yards long, very big, and they drop down chocolate into the boxes. This machine here is for the chip line, so it'll fill each of these boxes with 50 pounds of chocolate. And you can see some boxes filled up here. And each one, again, 50-pound boxes of chocolate. And then this machine here, this machine will take the liner and fold it over the chocolate, so the chocolate is no longer exposed. And here's the actual folding process. These two mechanical arms go and move the liner over the chocolate. This is an example of a well-folded liner. No chocolate is exposed, completely covered. Once the box in the next stage has to be closed and taped shut and labeled. So you can see this machine here would close the box and tape it, while this machine here would apply a label to the side of the box. Now I've had to blot it out. The labels are fairly big, about 6 inches by 10 inches wide. And once they go through, or once they're labeled, the boxes are passed through a metal detector, and then they're sent to the palletizers. These are the two palletizers. The left one is for the chunk line, and the right one's for the chip line. You can see boxes being placed on a pallet over here. Once the boxes are on the pallet, a worker will take them off and put them in storage, where they'll sit anywhere between 3 and 6 months before being shipped out to the client. So to quickly review that process, the box is assembled and a liner is inserted into the box. The box is filled with 25 to 50 pounds of chocolate. The liner is then folded over the exposed chocolate. The box is sealed, labeled, and placed on a pallet where it's stored until shipment. So the issue the chocolate factory was running into was problems with their packaging. They receive a number of complaints from customers about debris in the chocolate, being pieces of torn off liner in the chocolate, large pieces of cardboard that had gotten within the liner. They also had issues with the liner not covering the chocolate, boxes weren't closed or liner was sticking out of the box, and boxes without labels, so they couldn't identify what type of chocolate was in the box. So the following photos were actually taken from a client who received a shipment of chocolate and couldn't use the chocolate. You can see here that all the chocolate is outside the liner. And again, more chocolate outside the liner, in which case the client can't use this box of chocolate. So 50 pounds of chocolate's wasted. Again, missing liners and no liner at all. So this was becoming, well, actually, to give you an example, here's some correctly packaged boxes. The label, or the chocolate, is completely covered and unexposed. The box is taped shut and labeled correctly. The box is very clean looking. There's no issues with it, and the chocolate's fully covered. So this was becoming a big problem for the chocolate factory. The chocolate factory is on the hook to replace each shipment of chocolate if the customer can't use the shipment. So over the course of the last 5 years or so, the factory would have to replace 2 to 10 shipments of chocolate per year. Now, a shipment of chocolate can range between $10,000 and over $1 million. So over the course of 5 years, the chocolate factory was averaging $800,000 of replaced product each year. And that's the raw cost of the chocolate. That doesn't include the lost hours replacing the chocolate, such as melting it, mixing it, molding it, packaging, the lost office hours, procuring chocolate, procuring the raw materials, setting up shelf space. So that's just the raw material costs. The costs were much greater than the $800,000. So when we were looking at the problem, we knew we wanted some sort of vision system. So we were looking at 2 possible vision solutions, using a full color vision system and using a black and white vision system, specifically with the SICK inspectors. Examining the 2 options, the color vision system has a lot of capabilities. You can measure different hues and different colors against different colors. The problem was the system was very expensive. One of the quotes we received for hardware and lighting alone was about $70,000 to $80,000. In comparison, the black and white vision system with the SICK inspectors was far less expensive. Overall, the quote was around $20,000 for all the hardware, cables, and lighting. So about a third to a fourth the cost of a full color vision system. The full color vision system was also much more difficult to program. Cameras were very sophisticated, and if there's issues, the chocolate factory would have to call in a system integrator or third party to come fix the cameras, whereas the SICK inspectors are incredibly easy to use, and if there's a problem with the inspector, the site manager or a maintenance person can open up the camera, change the configuration, and make the fix on the line without having to call a system integrator. So we decided that we would use the SICK inspectors for our solution. We decided on a 3-stage solution. The first stage would be to set up the cameras along the factory line, configure those cameras, get the lighting, the cables, integrate them with the PLCs, and the network in general, get the inspections working. The next stage was to use the images produced by the cameras and create an image catalog and archive of those images so that we could review them later if there was an issue with the packaging. And the final stage was to create some type of client so that a site manager or a worker on the factory floor can see all the inspections that are going on at that moment and query the archived inspections. So here's our solution block diagram. You can see on the left side of the dotted line is the production network, while on the right side is the corporate network. On the far left, we have our PIM-60s, which are the SICK inspectors. We chose the PIM-60s because they're the most feature-rich cameras of the SICK inspector line. We integrated those PIM-60s with the PLCs on the production network and with a Windows server, which sat on the or between the production network and the corporate network. From the server, we would archive the images, catalog the images, and provide a web client. So computers and web browsers on the corporate or the production network could reach the server and see what's going on with my inspections and what happened with the inspections yesterday or a month ago, 2 days ago. So the first phase was installing and configuring the cameras. We had to procure the SICK inspectors, the PIM-60s, figure out how we're going to light each of our inspections, where we wanted to put the inspections, what filters we needed, different types of lenses to change the field of view on the cameras, and then integrate those with the PLCs and the production network. So you can see here, this is the machine we call the uncuffer. We have 2 inspections in this machine. We found that this machine provided the most strategic location for inspecting if there's debris in the chocolate and if the liner was folded over the chocolate. So you can see here, this is the first inspection that's checking for debris in the chocolate. Up top, you can see the SICK inspector here, all of our blue LED lighting, and here's the 50-pound box of chocolate down below. Here's another view at the ceiling of the enclosure and the uncuffer. We have the SICK inspector here and our blue LED strip lighting. This LED strip lighting was just Home Depot strip lighting, and it worked fairly well in the enclosure. The enclosure was fairly dark, so it was a very good source of light. When we used the lighting outside the enclosure, it didn't work as well. And you can see here, here's like a bird's eye view of what the camera is seeing. This isn't taken with the actual SICK inspector. This is just taken with another camera, but this is an example of what it's looking down on. So if there's a piece of debris, such as cardboard or liner in here, the camera's looking right at it. So the next inspection was to test if the liner was folded over the chocolate and there's chocolate exposed. So in this stage, the liner, these mechanical arms, fold the liner over the chocolate. We placed our 2 SICK cameras up above the chocolate looking down. You can see here, we have our 2 SICK inspectors. We have one here, looking down through these hydraulics and structure and cables here. And the reason we had to choose 2 SICK inspectors was because the field of view is so small, one inspector couldn't see the entire box. So with 2 inspectors, we set it up so one inspector would inspect half the box, and the other inspector would inspect the other half of the box. So here's another example image taken with my camera phone of what one of the inspectors would be looking at. So we had the debris test or inspection set up, and we had the folded liner test set up. So the final 2 was testing the label and testing the seal in the box. And we were able to accomplish this at one stage in the production line. And you see up top, we have this camera here looking down at the box, and that camera is looking for problems with the seal. And we have this camera at the bottom of the image here looking at the side of the box, and it's just looking for a label. Again, here's a bird's eye view from that seal inspection camera. So if there's a problem with the box, there may be blue liner sticking out of the side. The lid may not even be covering the liner. Maybe exposed chocolate. The seal might be too wide. So the SICK inspector can look up for all those things, and it'll know if there's a problem with the box. Here's another view of the label inspection. The label's fairly big. It'll sit in the entirety of this space. And the camera just uses a simple object detection test to find where the label is on the box and if it's there. So here's an example of the SICK configuration tool used to configure the cameras, and 8 of our cameras on the line. To date, we have 3 cameras on the chip line and 5 cameras on the chunk line. The chip cameras are checking for debris and inspecting the fold, so 2 cameras on the fold. And on the chunk line, we have the debris test, the 2 liner tests, a seal test, and a label test. Here's another example of the configuration tool. This is the actual chip debris test. And here we have 2 different inspections going on. So you can see the image, and this is the actual image on the line taken about 2 days ago of what the camera sees. And we have 2 inspections, these 2 green boxes here. And they're both doing the same thing. They're both blob tests. So they're looking for a big white blob. With the blue filtering, any blue liner that falls into the chocolate pops out. It's very high contrast. The same goes with a piece of cardboard. The cardboard will pop out bright white against the dark chocolate, so it's very easy to detect those blobs. Now, the reason we chose 2 blob inspections was because occasionally the liner on the side would fold over the chocolate and into our inspection region. So the outer blob test is a bit less strict than the inner one. The inner one is very strict, so if there's any blobs, it's going to stop this package and mark it as failed. Whereas if the liner's folded over, such as here, it's not going to stop the package. Here's one of our chip fold inspections. So you can see the camera can only see half the box. In this box, the liner is perfectly closed. With the blue filtering and the blue lighting, the liner pops out and it's just 100% white. So if there's any exposed chocolate, it's a very dark spot on the liner. And for here, we used 2 tests as well. We used a blob detection test to look for big chunks or open regions of liner, and we used a pixel counter. If there's a handful of chips spread out on the liner, the blob test might not see it. We're looking for fairly large blobs of chocolate, whereas the pixel counter will see, oh, there's so many pixels above a certain threshold, okay, that failed. So with the cameras installed on the line and configured, we integrated them with the PLCs on the network. The way we set this up was if the package failed, the line would just stop. Unfortunately, this is a fairly slow speed application to where boxes come through every 10, every 30, every 40 seconds. So if the line has to stop, an operator will see the line's backing up, they'll go fix the package and then start the line up again. In a high-speed application, you'd want to have a kick-out line to where if a box fails an inspection, it would be automatically taken off the line and production line would keep moving. So with our inspections configured with the PLCs, we moved to the next phase, which was archiving and cataloging all the images taken by the SICK inspectors. And to do this, we created our own Windows application that would take those images, compress them, store a bit of metadata about them, such as what inspector took the image, did the image pass or fail the test, what time was the image taken, and we take that information and store it to a database, while the image would be compressed and saved to a mass storage network drive. So you can see here's another block diagram of that portion of the system. So the PIM60s, again, are the SICK inspectors along the packaging line. Those PIM60 inspectors, each time, we configured them to where each time there was an inspection, they would send the image to our Windows server in the form of bitmaps. This is a built-in function of the cameras. All you need to do is set up a Windows server as a FTP server, and the cameras will see that, authenticate, and write images to that server. So our custom software, which we called the archiver, would look at those inspection bitmaps, determine the metadata from that inspection, when it was taken, the camera, whether it passed or failed, and store that metadata to a SQL server on the network, while the image was compressed and stored on a mass storage device in our image archive. So that was the conclusion of that phase, is getting the images archived, image data stored, and compressed. So the final stage was creating some type of client to look at the live images and look at the archived images. And we wanted the client to be available on both the corporate and the production network. So we had two choices going about this, as creating a web client or creating a desktop application. And we opted to make a web client so that any web browser on any computer on the network that could see the server had access to the images and the live images, the archive, and all that information. A desktop application would require installations on every computer, a bit more maintenance and upkeep. So this is an image from our live view on the web page. So an operator or site manager, someone on the production network, or someone in the office would open up a web browser and punch in the server address, and it would take them here. Now here they could see the images that were last taken on the line. So if an image updated on the inspector, it would update on the screen a second or two later. So it's nearly real time. On the top here, we can see our 3 chip inspections. We see the chip debris inspection and the 2 chip fold inspections. On the bottom, we have our chunk inspections, the debris inspection and both the fold inspections. Here we have the tape inspection that looks for the seal on the box. And here's our label detection, just locating the label on the box. And then this portion of the web client is our query tool that allows anybody to go through and query images taken by any of the inspectors. So you'd open up this page, you choose a start time and end time. So right now we're searching from February 1st to February 10th. You select your camera. In this case, we wanted a debris or open inspection. We wanted the chip line camera. You choose your decision. In this case, we wanted all photos. You can choose whether you want to see all the ones that passed or all the ones that failed. The number of results. In this case, we're pulling in 250 results per page. And then you could order the results, newest to oldest, oldest to newest, and the image sizes you want. So the query tool will return 250 results, the first 250 results from that time period from the chip open camera. And you can see here that failed packages would turn red. This one specifically is a false positive. It should not have been detected by the system. So that would have stopped the production line. But any image that was detected as failed would show up red here. You could also click on the images and they would expand full screen so you can get a better view of the image. So what were the results of the project? So to date, since October 1st, we've had 6 inspections running on 2 packaging lines. Those inspections are the 2 debris inspections and the 4 folded liner inspections. The seal inspection and the label inspection, we've integrated them on the line, but we haven't put them into production. They don't stop the line when there's problems with the box. We're waiting for hardware and more triggers and sensors for that. But with those six inspections running since October 1st, we've taken nearly 1.2 million images of packages. And we're seeing about 150 defective packages per day. Of those defective packages seen by the vision system, we're detecting 98.4% of them correctly. That's to say that about 1.6% are incorrectly detected. They're good packages that the system said failed. Now, on the other hand, we're also seeing 5.2% of defective packages that are undetected. These are packages that should have failed, but they snuck by the inspections. Ideally, we want to see 100% of defective packages detected and 0% of defective packages undetected. So to date, the chocolate factories had to issue 0 replacements on chocolate that was inspected by our vision system. So that's the perfect result. We don't want any replacements on this chocolate. So the return on investment, the chocolate factory was spending about $800,000 a year replacing chocolate to customers. The total cost of hardware for the system was around $20,000, while the cost of DST Controls as the system integrator was around $35,000 for the project, installing the cameras, configuring them, working with the PLCs, developing the image archiver, and developing the web client. So in the first year alone, we've had no replacements, so we've saved about $745,000. And that cost, assuming that there's not many replacements, that cost is only going to go up as the cost of hardware and the cost of DST Controls and a system integrator decline. So what are some of the other benefits to the customer? There's a significant quality assurance improvement. Before, the chocolate factory was only using a metal detector to test their chocolate. Now, they're looking for debris in the chocolate. They're making sure the box is labeled, none of the chocolate is exposed, and if the box is sealed shut. They also have readily available access to any image ever taken on the system with the web client. If a customer complains, they could go back through and say, oh, no, there's no problems on the line that day. Like there must be something else going on. We don't need to replace that chocolate. Additionally, the SICK inspectors were very inexpensive in comparison to the full color cameras. And for all intents and purposes, they worked very, very well. The SICK inspectors are also very easily configurable. The site manager or maintenance people can open up the SICK configuration tool, open up a camera, and make changes to the camera need be. They wouldn't have to call in DST Controls to come in and fix anything or maintain anything. So that's all I have for today. Thank you for attending. Below is my contact information, the contact information for Lonnie Bowling, our Associate Director of Industrial Data, and the contact information for Ricardo Areta. I can't pronounce it. Anyway, thank you for attending.
So thank you, Alan, and thank you, Ricardo. We're opening it up to questions now. So if you have any questions, you can enter them into the Q&A box or the chat box. We do have a few, Alan and Ricardo, that have come in during the webinar. The first one is for Alan. What were some of the difficulties configuring the cameras?
The cameras themselves are fairly easy to configure. The SICK tool is very easy. The hardest part is probably getting the lighting set up and then finding or creating an inspection that's very, very redundant, such as you don't want inspections to change every time. If the lighting changes between inspections, it's very problematic. Pretty much you just want the same inspection every single time. And getting an environment that does that is probably the most difficult part. The cameras are very easy in that sense.
Okay. Another question that just came in. How do you determine the 5.2% undetected failure rate? Were these identified by customers?
No, they weren't identified by customers. I went through and I sampled about like 10,000 images from all the cameras, and went through and just eye tested it. It took a while, but yeah, we haven't had customer complaints on any of that chocolate to date.
Okay. What happens to failed packages?
Currently, failed packages are just fixed by the operators. When an inspector detects that it fails, the line just stops. The packages move pretty slow on the line, so they usually don't get too backed up. An operator will just come over, fix the package, and then start the machine up again. Worst case scenario, they actually have to take the package off and then just dump it, pig feed at that point.
Okay. And then why did the chocolate manufacturer use a system integrator if the cameras are easily configurable?
The big thing we provided was the extension on top of the SICK cameras. The SICK cameras could be configured and installed. They could network them with the PLCs, and they could have them send the images to a server. What we provided was that ability of cataloging and compressing all the images, saving a lot of space, and then the web client, which allowed them to find those images very quickly and view the images very quickly. Those two pieces aren't provided by SICK and don't come out of the box. So that was the main decision point there.
Okay. So it looks like that is all the questions. So thank you, Ricardo, and thank you, Alan. This was a great presentation. And if anyone would like to review any portion of this webinar, a recording will be available on our website, EandM.com, and also on our YouTube channel this afternoon. Also, if you think of any questions after the webinar, feel free to email us at eandmwebinar@eandm.com. And thank you, everyone, for attending. Have a great weekend.